Hello everyone. In this sixth tutorial of the series on fire and smoke with a fluid simulator in Blender 4.5, we'll complete our overview of the domain object settings. In particular, we'll go through the main parameters of the field weights, volumetric data, viewport display, and render sections. Some of these parameters will help us better understand certain material properties, called attributes, which we'll cover in the next episode. As mentioned in the introductory video of this series, the written version of this and other episodes is available for free download at the link you'll find in the description. Regarding field weights, for now, all we need to say is that the simulation can be influenced by external forces, and here we can define the extent to which these external forces affect the simulation elements. One of these external forces is gravity, which is enabled by default at the scene level and is what actually makes fire and smoke rise upward. So you can get a sense of how these fields work by adjusting the gravity value in the field weight section. Among other things, the field weights parameters are animatable, which means you can modify the influence of a given force during the animation from this panel without changing the force's own settings. There is also a control called all, which lets you apply the same value to all force fields affecting the simulation. The effector collection field lets you restrict the simulation to only the effectors belonging to a specified collection. By default, it's empty, meaning all effectors within the domain will influence the simulation. In any case, we'll talk about force fields and effectors in later episodes, so for now we'll close this section. When I talked about the cache earlier, I focused on what information was stored and how to reuse it, but not on how it's stored. These parameters are found in the volumetric data section of the cache panel, and they let you specify the format used to store voxel data on disk, along with compression and precision settings. The best compression for disk storage is zip, but the default option is BLOSC since it's multi-threaded and therefore faster. Half precision saves data at 16 bits, while full saves at 32 bits, which may be excessive in some cases. The default settings are OpenVDB, BLOSC, and half. In most cases, these defaults work just fine. In the render section, there's actually only one parameter, which relates to motion blur. Motion blur must be enabled at the project level in the Render tab, and as we'll see in a rendering tutorial later on, in many cases it can produce a very pleasing effect. The core of this tutorial, however, is the viewport display section, which contains many interesting options that let us visualize some of the information contained in individual voxels. This will help us better understand certain domain attributes that we'll use in the next episode to modify fire and smoke materials. To begin, you should know that the 3D view displays multiple slices for each voxel. Here you can specify parameters such as smoke thickness, interpolation quality, and the number of slices to calculate per voxel. Increasing the smoke thickness can make it stand out more, making its behavior easier to observe. Keep in mind, though, that the parameters in this section only affect how the simulation looks in the 3D viewport in solid mode, and do not affect its appearance in the final render. They are purely for visualization. If you want to see a single slice of the entire domain, you can enable the slice option and choose an axis. It's like cutting the domain along that axis and viewing its cross-section. At first, the display will change with every camera movement in a 3D scene, because the slicing axis is set to auto by default, adapting automatically to the observer's viewpoint. The position value ranges from 0 to 1 and corresponds proportionally to the size of the domain along the chosen axis. I'll show you an example using the y-axis and adjusting the position value. Vector display shows, within each voxel, the vectors of velocity, guides, and forces. Guides are special objects that, like force fields, influence the behavior of fire and smoke. At the moment, we don't have any guides or forces in the scene, so we can only see the velocity representation, which is inherent to the fluid itself. The other options in this section allow us to adjust the look and size of the graphical elements used for visualization, making them easier to read. I've saved the grid display section for last, since I think it's the most interesting. It lets us visualize some properties of the simulation, such as heat or density for each voxel. As we know, the domain is divided into voxels, and the resolution is clearly visible from the cube subdivisions we see in grid display. For each voxel, the domain contains information such as temperature and density. By adjusting the color ramp, we can see the range of values for these properties across all voxels. This kind of visualization is particularly useful because some of these properties are stored as attributes accessible in the shading section. In the next episode, we'll see how to retrieve them there to modify the material of fire and smoke voxels, for example, based on their temperature. With this tutorial, we've completed our overview of the main flow and domain parameters that control how the base simulation is created. In the next tutorials, we'll move on to rendering aspects and to other elements such as guides and forces, which can disturb or alter fire and smoke. If you enjoy my content, the best way to thank me is to subscribe to the channel and leave a like on the video. Thanks, and see you soon.